The last video we went through performing some more operations with matrices, and in this video I'm going to talk about a very important operation with matrices, which is called the determinant. So the determinant of a matrix A is defined as some quantity that results from operating on each of those elements. So this is better explained by some construction. So before I begin to even explain what this is, let's look at a 2 by 2 matrix. So let's have a 2 by 2 matrix. Minus 2. Let's have this. Now, let's call this A. The determinant of a matrix is usually denoted as this. So we use straight long bars on the side. So we're going to have 2. So determinant of A is going to be long bars 2, 3, 3, minus 2. So what we're going to do to calculate this quantity is we're going to cross multiply elements. So we're going to multiply this element by that element, and we're going to subtract this element by that element. So what we're going to have is 2 times minus 2 minus 3 times 3, which is 9. And then this is going to give us minus 4 minus 9, that's minus 13. So as you can see, the determinant of this matrix is basically just a numerical value. And this is a very important concept because when it comes to finding the inverse of a matrix, we will need to calculate the determinant in order to calculate that inverse. So as you may imagine, the main focus of linear algebra and matrices is to solve systems of linear equations like 2x plus 2y equals to 1, and then 3x minus y equals to 5. So basically what we want to do is we want to find the values of x and y that correspond to this system. So what we can do is we can write this in matrix form as follows. So we can put all the coefficients here in a single matrix, and then we're going to multiply that by a column vector xy, and then that's going to be equal to whatever values we have on the other side. And the whole idea of finding x and y is to invert this matrix. So, you know, in linear algebra, we don't have that thing where we can divide a matrix by a matrix. So instead what we do is we take the inverse, which is a different kind of operation. So it is usually denoted by a minus 1. So 2, 2, 3, minus 1, minus 1, 1, 5. And basically, in order to find the inverse of this matrix, or essentially just to perform this kind of operation, we need to calculate the determinant, because that's going to be a very important number that goes into that operation. So this is something that we will cover in the next few videos, but for now we need to break this into different steps. So for now we're just going to focus on what the determinant is. So basically what I'm going to do now is I'm going to basically explain to you how this works. So the determinant of a matrix only exists if A is a square matrix. So a square matrix is one that has the same number of rows as columns. So if the matrix A is a square matrix, then there exists a number that identifies as the determinant of A. And the determinant is essentially just a deconstruction of the elements. So for a 2 by 2, what we have is we have a cross multiplication. So basically we get the first element times this element, and we're going to subtract the product of those two other elements, and then we get a numerical value from that. Now what happens when you increase the dimensions? Now let's see what happens when we increase the dimensions of this. So let's say now that our matrix A is a 3 by 3 matrix, and we're going to have 3, minus 1, 0, 1, 2, 3, 1, 0, minus 2. Now, in order to find the determinant of this, what we're going to do is we're going to rewrite this minus 1, 0, 1, 2, 3, 1, 0, minus 2. And remember, we know how to perform an operation with a determinant of a 2 by 2 matrix, but how about a 3 by 3? Well, what we're going to do is we're going to take the first row, and now we're going to take the first element. So I'm going to draw this in a different color. So we're going to take the first element, and basically we're going to block the row and the column that it belongs to. So it belongs to the first column, so we're going to block that, and then the first row, we're going to block that. And what we're going to do with this is we are going to multiply this 3. So I'm going to write it down here. This 3 is going to be multiplied by the determinant of these other elements here. So basically we're blocking that column and that row, and we're multiplying 3 diagonally by the determinant of this. So we're going to draw it like this: 2, 3, 0, minus 2. And this is an operation we can perform because we already know how to perform how to calculate the determinant of a 2 by 2 matrix. We just cross multiply like that. And basically now what we're going to do is we're going to take the next column. So we're going to take the next element, which is minus 1. And we're going to do the same. So in this case, what we're going to do is we're going to block the column and the row that it is on. In this case, it is on column 2, row 1. So we're going to block this entire row, and we're going to block the entire column here. So what we're going to end up with is we're going to have minus 1. And the reason that minus is there is that for a 3 by 3 matrix, the sequence goes plus, minus, plus. So that's just a sequence that is attached to it. And there's a mathematical reason behind that, but I won't go into detail into that. Just know that the first element is a plus, the second element you need to multiply by minus, and then the third element is a plus again. And the sequence goes like this for any dimension. So if you have, for example, a 5 by 5 matrix, what you would have is the sequence, so plus, minus, plus, minus, plus. And it's a very easy sequence to remember. So just remember the first element is always a plus. So minus 1. Now the determinant here is going to be the elements that are not included in this column. So that's going to be 1 and minus 2. So 1, 3, and 1 and minus 2. And then finally for the third element, we're gonna block this column and this row, and we're gonna get the determinant of this. So basically we're multiplying this by the determinant of these 4 elements. So that's going to be 1, 2, 1, 0. Now just to remind you that basically we can perform this operation first before we multiply, because the determinant is just a single number. So we can perform the multiplication later on. So let's see what we get from this. Well, from this we get 0, of course. And from this we're going to get 3 times. So 2 times minus 2, that's going to be minus 4. Minus 3 times 0, that's 0. And then for this one we're going to get plus 1. And then we're going to get 1 times minus 2, that's minus 2. Minus 3 times 1, so that's 3. And then we're going to add this together, so that's minus 12, minus 5, and that's minus 17. So this is the determinant of that matrix A. And there's a very easy way that we can perform this on Octave. So this is what we'll be using in the next videos, because as determinants get larger and larger, you can imagine that the complexity of the calculations is going to increase exponentially. And at some point, it's going to be completely useless to do it by hand when we have computers that can do it in literally a few seconds. So let's write down this matrix. So matrix A is going to be, Now remember, for matrices on Octave, what you want to do is you want to put all the row elements separated by a comma and column elements separated by a semicolon. So we're going to have 3, minus 1, 0. Now we're going to have 1, 2, 3. And then the third row is going to be 1, 0, minus 2. Alright, so we have our matrix A now. So let's calculate the determinant by using this function. So it's just det A. So that's just the determinant of A. And there we go, it's minus 17. So as you can see, that only took a few seconds. And when we did it by hand, it took quite a long time, it took a few minutes. So obviously, in the future, we will be using this computational software instead of just doing it by hand. But it's really good to just know how this whole process works, because it's really, I think it's really important to understand the mathematics behind it. So now that we understand how this works, we can begin to explain what will happen for higher dimensional determinants. So now instead of a 3 by 3 matrix, let's see what happens when we have a 4 by 4 matrix, and that one is going to be a little bit more complicated, and you will see why. You can begin to imagine what this is going to look like. So let's have matrix A 1 0 1 minus 1 2 3 1 5 0 5 6 5 minus 1 3 1 2. And as I mentioned before, remember, in order to find the determinant of a matrix, the matrix needs to be square. So if we don't have a square matrix, then the determinant does not exist, essentially. Now, what is going to be the determinant? Well, it's just going to be the same thing. 1 0 1 minus 1 2 3 1 5 0 5 6 5 minus 1 3 1 2. Alright, so we're gonna get the first column again. You guessed it, we're gonna take the first element, we're gonna block the first column and the first row, and we're gonna multiply this element 1 by the determinant of this whole chunk here, because those are the only elements that are not included in this column and this row. So we're gonna have to calculate the determinant of that. So that's the 3 by 3 determinant, 1 5 5 6 5 3 1 2. And for this one, we're going to have to perform the same operation. So we're going to have to take the first row, then this, calculate the determinant of that. So this is going to be decomposed into a sum of 3 numbers. And then we're going to grab the second number, and we're going to make up the determinant of that, which is going to be, remember, the sequence goes plus, minus, like that. So we're going to have these elements and these elements here. So that's going to be 2, whoops, not 3, that should be 1 5 0 6 5 minus 1 1 2. Those are only the 2 first elements, and now we're going to have this one. So the next element is going to be positive, so that's going to be plus 1 times the whole determinant. So this is going to be a 3 by 3 determinant again. So if we block this column and that row, we're left with these 2 columns and this one. So that's going to be 2 3 5 0 5 5 and then minus 1 3 2. And for the last one, we're going to have minus again, minus 1 times the determinant of this whole chunk here. So that's 2 3 1 0 5 6 minus 1 3 1. And you can imagine that in order to perform this calculation, we need to actually calculate each of these 3 by 3 determinants first. So that's quite a tedious process. So that's why for determinants that are essentially higher than 3 by 3, we just use the computer. And this is just to give you an idea of how it works. But you just learned how to use Octave to calculate this kind of thing. So you just need to write the 4 by 4 matrix here, then use the function det_a, and that gives you the answer straight away. So this is just to teach you that. And in the next video, we're going to be looking at minors of a matrix and cofactors of a matrix. And that's going to be the second step in finding the inverse of a matrix that will allow us to find the solutions to a system of linear equations. So that's what we will be doing in the next video.